Today we're going to look at summation notation, how to determine whether it's arithmetic or arithmetic, however you say it, geometric or neither, and then how to evaluate the summation given those that information. So summation notation, remember, is this big, funny looking E, which is capital sigma. It means sum. Lowercase sigma is the standard deviation, and that's used in statistics. So capital sigma means sum. We want to find the sum. And there's usually a number on the bottom, say n equals 3 to 5. And then there's an equation in here. So I'm just going to make up one, 3n plus 7. So this is our rule. Now, when we're evaluating this, what this actually means is I want to take the values of n, starting with 3, and plugging them in. So 3 times 3 plus 7. And I'm going to add that to the next number, 3, 4, 5, all the way up to 4, or up to the 5. So 3 times 4 plus 7. And then plus 3 times 5 plus 7. So this is how you're going to do it by hand, writing it all out, writing each one out. So this would be 9 plus 7 is 16, plus 12 plus 7 is 19, plus 15 plus 7 is 22, and then we can add that up. So this is 35, 57. So the sum from 3 to 5, the sum from n equals 3 to 5 of the rule 3n plus 7 equals 57. Hopefully I added that up correctly. So to do it by hand would mean to plug in every value and then show all of the work as I've shown here. But that's not always the most efficient way. If it's not arithmetic or geometric, the only way to find it is by hand. So an example, okay, remember that arithmetic is linear. So it looks like mx plus b, really, right? 3n plus 5, 1/2 x plus 6. Looks like a linear equation. There's no exponents, and the variable is not in the denominator. If it's geometric, it's exponential. It looks like a times b to the x, where the variable is in the exponent, 2 times 3 to the n plus 1. And it's really a1 times r to the n minus 1 power. So, or 4 times 1/2 to the n minus 1. That's what we're looking at. So if the variable is the exponent, then it's exponential. Anything else is going to be neither. So neither might be quadratic, n squared. It could be cubic, n to the third. It could be rational, 1 over x. Those are the neithers. The neithers need to be done by hand always. There's no shortcuts. The arithmetic and geometric we can actually use the rules for. So let's look at a couple examples from your homework. J equals 0, that's a J, to 10 of 1/2 J minus 3. So this is number 7 on worksheet 65. So we're looking at the equation. The first thing we want to look at is this equation here and determine whether it's arithmetic, geometric, or neither. My variable does not have an exponent on it, so it's, and the variable is not the exponent, and it looks linear. It looks like the mx plus b form, so this is going to be arithmetic. And so our sum of arithmetic is S of n equals n over 2 times a1 plus an. And a1 just means the first term in the series. In this case, the first term is actually going to be what we get when we plug in 0. And then our last term, an, is going to be what we get when we plug in 10. So we're going to find a1 by plugging in j equals 0. So the first term is when the j equals 0. So 1/2 times 0 minus 3 is negative 3. So our first term of this series is going to be negative 3. And then our last term, an, is when j equals 10. So we're going to plug that in. 1/2 times 10 minus 3 is 5 minus 3, which is 2. So an is 2. And now how many terms are there going to be from 0 to 10? That's n. N is the number of terms. So you have to count. When j equals 0, j equals 1, 2, 3, 4. How many terms is that actually? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's really important when you're looking at that, you really see what you're finding. That's how many terms from all the counting from 0 to 10. Now a quick way to do that without actually writing it all out is 10 minus 0 plus 1. And that gives you the number of terms. So the n in this case is 11. So the sum of the 11 terms is 11 divided by 2 times a1, which is negative 3, plus an, which was 2. And so that is 11 over 2 times negative 1. So negative 11 halves is the sum of 11 terms. Okay, so now let's look at number 13. The sum from n equals 1 to infinity of 1/5, 3 to the n minus 1. Now our first clue that this one is different from the rest is this infinity symbol at the top. This means this is an infinite series. And if it's infinite and if it's arithmetic, it has no sum because it's just going to keep adding and adding and adding and keep getting bigger and bigger and bigger. Geometric, remember geometric looks like a 1 times r to the n minus 1 power. That is our form here. So in this case, our a1 is 1/5. Our variables in the exponent, our r is 3. And when we have an infinite geometric sequence or series, and the r is greater than 1, this is divergent. It's going to keep getting larger and larger and larger and keep adding to itself. So there is not going to be a sum. So this one we say no sum. We'll look at 14. The sum of j equals, where's my eraser? J equals 2 to 8 of negative 2 times 2/3 to the j minus 1. So this one, again, our variable here is in our exponent. We have the a1 times r to the n minus 1 power. So it looks like we have a geometric sequence. So this is geometric. But it doesn't start with a j equal to 1. So we want to find our an and our a1 because this one is a little bit different. So we're going to use our sum formula that has the a1 minus an times r over 1 minus r, as opposed to the other one, which is a1 times 1 minus r to the n over 1 minus r. I either one is going to work, but the bottom line is we have to actually plug in A1, or we have to plug in j equals 2 to find what that first term is going to be. So if I'm going to do that, it's negative 2 times 2/3 to the 2 minus 1 power. So negative 2 times 2/3 to the 1. And so my A1, my first term in this series, is going to be negative 4/3. And so like I said, we could use either of these formulas. In the first one, we need A1, we need R. We know R is 2/3. Now we know A1 is negative 4/3, and we need N in this formula, and in this one we need AN. So to find AN, to find the AN for this formula, I would need to plug 8 into this. And to find N, I need to count how many from 2 to 8. So I would be plugging in 2, 3, 4, 5, 6, 7, and 8. And we want to say that's 6, but when we actually count it, we have 1, 2, 3, 4, 5, 6, and 7. So remember on the last slide we said it's really 8 minus 2 plus 1, so that we get how many terms. Because when you subtract off 2, you're not counting that as one of the terms, and it actually is one of them. So now we know N is 7. So actually it's probably easier to use the first formula, because then I don't have to calculate what AN is. So sum of 7 terms is A1, negative 4/3, times 1 minus R, which is 2/3 to the 7th power, over 1 minus 2/3. And then we're going to do this in our calculator. We get negative 4/3 times 1 minus, that's 128 over, I'm going to need a calculator for 3 to the 7th, 2187 over 1/3. 1 minus 2/3 is 1/3. So then I get 1 minus the fraction 128 over 2187, and that is negative 4/3 times 2059 over 2187, and we're going to times that by negative 4/3. And keep this in fractions. Let me move. Okay, so let's see. We're going to multiply this. And remember, this still has a divided by 1/3 factor. Let's actually do this right now. Negative 4/3 times 2059 over 2187 times the reciprocal 3 over 1. And now my fractions can cancel. So now I just need to multiply the numerator by 4. And I'm going to get negative 8236 over 2187. That's my exact answer. And when I put that into the calculator, that's approximately negative 3.766. Looking at another example, one that we might have to do by hand. Let's look at number 11. The sum from n equals 0 to 4 of n times n plus 1 over 2. This isn't linear because I have two variables. I have n and n. N times n makes it an n squared, so it makes it quadratic. So it's not geometric and it's not arithmetic or arithmetic. So I have to just do this by hand by plugging in n equals 0, 1, 2, 3, and 4. And then I'm going to add it all up. So when I plug in n equals 0, we get 0 times 0 plus 1 over 2 is 0. Because 0 times anything is 0. Plug in n equals 1. 1 times 1 plus 1 over 2 is 1 times 2 divided by 2, which is 1. Plug in 2. 2 times 2 plus 1 divided by 2 is going to be 2 times 3 divided by 2. The 2's cancel and I just get 3. Plug in n equals 3. 3 times 3 plus 1 over 2 is 3 times 4 over 2. 2 goes into 4 twice. That makes it 6. And plug in 4. 4 times 4 plus 1 over 2. We got 4 times 5 divided by 2. 2 goes into 4 twice. And that's 10. And now we're going to add up 1. 0 plus 1 plus 3 plus 6 plus 10. So this is 10 and 10, which is 20. So the sum equals 20. So that's what we do when it's not arithmetic or geometric. It's not an infinite geometric. We just plug them in to solve. And now let's look at one that is infinite, that we can use the infinite formula for. So let's look at 18. The sum from n equals 2 to infinity of 10 times negative 4/5 to the n minus 1 power. So this is our geometric form, a1 times r to the n minus 1. But we need to pay really close attention to the fact that this is going to start with an n of 2. So I actually have to plug that in to find the first actual term of this series. And then identify my r. R is negative 4/5. As long as the absolute value of r is less than 1, it's convergent, meaning it has a sum. And we can use our formula, a1 divided by 1 minus r, to find it. So let's find our a1. a1 is going to be 10 times negative 4/5 to the 2 minus 1 power. That's 10 times negative 4/5 to the 1 power. And that's just negative 4/5. 5 goes into 10 2 times. So a1 is in this case negative 8. And so my formula is a1 negative 8 divided by 1 minus r, which is negative 4/5. And so that's negative 8 over 1 plus 4/5, because when we subtract a negative, we add. And so that becomes 1 and 4/5. Let's make that a mixed number. 5 times 1 plus 4 is 9/5. So we have negative 8 over 9/5. And now we're going to multiply by the reciprocal. Negative 8 times 5/9, which is negative 40/9. And we can leave it as that fraction. And that's our final answer. If we wanted to get a decimal approximation, we get negative 4.44.